Okay. We talked about oversampling before in chapter 2. So now we're going to do the oversampling now. How to set up oversamples. So when do we need oversampling? Oversampling can be used for asymmetric costs that we talked about. Okay. Or we can do it for rare events. Rare event will be when the positive class is very few, okay, like 1%, 2%. 99% is non-event. Then we want more events in our sample. So those are the two cases. So examples of rare cases. Okay, so responses to promotional mail is notoriously very, very small. Fraud cases and debt defaulters, these are all rare cases. Okay. Random sample will have too few cases of the target. So we need, for modeling purposes, we need to boost the number of C1s. So typically we'll use 50% C1, 50% C2. So in the original data set, maybe 2% is the cases. Now you take all those 2% into the training and put an equal number of non-events, then now you get 50%. Okay? So that's your oversampling. Okay? So oversampling strategies, so you do without replacement. Okay? So that means you don't repeat or you don't resample the same observation again. Okay? That is oftentimes is not feasible, especially if you have very few, like 1% of the cases or events, 99% non-events. That 1% is not sufficient for you to build enough of a sample for us to run the models. So then we take that 1% or maybe half of 1% because you want to keep the half for validation. So you take half of that 1% and then just double it, triple it. So then you're now resampling. Okay? So so that you will have sufficient number of cases. So that would be oversample with replacement. Okay? Without replacement is preferable, obviously, but sometimes it may not be feasible. Okay, so what is the procedure? Okay. Now, so you separate the events and non-events. Okay. Let's assume that we want to do 50%, 50%. Okay. So you take the events and then take 50%, put them in training, 50% put them in validation. Okay. And in the training, okay, you get equal number of non-events. So now you have training set is 50% event, 50% non-event. Okay. So training set is oversampled. Now, how do you sample validation set? Okay, there are two approaches. You do the same thing in validation set also. Okay, put equal number of non-events, so you get same proportion like in training. But when you do that, you're oversampling the validation set. Also, then you need to do some adjustments to the confusion matrix, otherwise it's not accurate. Or you can select enough number of non-events into the validation set so that the probability is the same as in the original data, in which case you are not oversampling the validation set. Okay. So when it comes to oversampling procedure, your training set is always oversampled. You have to do that. Now, validation set, there are two possibilities. You can either oversample validation set or not oversample validation set. Okay. So let's all right. Well, we're running out of time. So let's look at the two cases. We look at how to do it next time, but let's look at some concepts here. So how do you score and evaluate validation set? Okay. If the validation set is not oversampled, then you don't have to do anything. You do your training and then predict the validation set and do the calculations. Because validation set is not oversampled, so you don't have to do anything at all. But if the validation set is oversampled, then we have to fix it. we have to fix the confusion matrix. Okay, so this is, how do you fix it? Okay, so here, suppose if the original data is 90%, 98% non-responders, 2% responders. Okay. Now your validation sample is now oversampled, just like training set, 50-50. Then you have a weight. Okay, you divide this 50% by the original data probability, and that's what's going to give you the weight. So because your non-responders, okay, so you need to adjust for non-responders by that weight, and you need to adjust the responders by that weight. So you divide that into each of the classes. So if you have, so this is your confusion matrix, right? Without reweighting. Okay. So you run your validation set through prediction, and you get this classification matrix. So here is how you will adjust the confusion matrix. You divide by the, so predicted 0, okay, actual 0 here, actual 0, the weight is, okay, non-responders, the weight is 0.5102, so you divide these two numbers by 5102. The weight for responders is 25, so you divide this by 25. Okay. Because in the oversampled, we had 25 times more responders. So therefore, we have to adjust for that. So once you have recalculated the values, then you do the accuracy measures. You do your error rate, accuracy rate, and sensitivity and specificity and everything else will come after that. All the measures that we have discussed so far then can be computed with the reweighted confusion matrix. Okay, so we'll, it's just what we have is the resampling in R. We'll finish that first thing on